Welcome to Gen.Struct.2 and Lat.Forces, lesson 2 quiz, example number 4. I guess question number 4. Anyways, what it says is select the incorrect statement. Secondary stresses and trusses are A, B, C, D. And we're looking for the incorrect, so I'm going to put that in big letters so we know incorrect statement. Alright, so let's just go through these and see what's incorrect or correct. So secondary, well actually before I do that I'll go over what secondary stresses are. When you build or design a truss, let's just do a quick simple truss here. Let's say the truss looks like this. And let's put some vertical bars in there. Okay, and they are bearing right here. So there's your truss. When you load a truss, what you're assuming is every single member is tension or compression only. So I'll write that up here, tension or compression only. Or compression only. And I guess that's all I'm going to say. So when you load this truss, you're not going to load it like so. You're not going to put that there, because what would that do? That would bend it like this, and therefore it's not tension or compression, that's now bending. So we do not want to do that. That's bad. We want to load it at every panel point, and these are called panel points. Right here, we can put one right here. I'm going to change color back to green, and you'd actually find laterals, or not laterals, but verticals right there. So this is one panel point. This is a panel right here. They call this a panel. And then when you go to here, that's another panel. So, and this is called your top chord. Up here is your top chord. This is your bottom chord. And these are known as diagonals. And you can call these verticals. And I'm sure there's other names for them, diagonal. But that's what I generally use, and you can use whatever you want. But top chord, bottom chord, diagonals, and verticals. All right. So you want to load. You're assuming that this truss is loaded at each one of these points. Here, 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 here. It has to be at one of these panel points, because what that will do is that will ensure that it's transferred equally to tension through tension or compression. So that's the way it'll work. And if you'll find out, if you look at a truss and you get it down to the details, you'll see that that's actually how they make these. Like if you're making a truss, for instance, you'll have this sit up above that top chord, and this will come up and somehow sit up. It'll be loaded like that. So here's your slab, or your whatever that, assuming that you're walking up here, you can have a through truss, which means you kind of walk through the truss or drive through the truss or whatnot. That means that let me switch colors, that the walking surface would be down here. But typically in building design, you're not dealing with anything right there. A through truss, meaning you're going through the truss. And that'd be typically for bridges. I don't know of any building application which would be through truss. But they're out there. So you'd have a slab or whatnot. So let's say it's a bridge or a roof, and the guy's up here. So you could do corrugated metal from there to there, but really that corrugated metal is never touching this top chord right here. There's going to be a little space. The corrugated metal will distribute the load. That will go that will go to this one, so it'll come right here. This will be, the distributed area is right here. For this one, distributed area is right here, halfway, and so forth. So it's actually loaded right there. And then you look at the truss, and you're loaded that way. Anyways, I think that's a quick 2-second or 4-minute dirty way of explaining trusses and how they're loaded. So when you're loading a truss, you assume that it is loaded at the panel points. All right, so let's look at these and see if that is any help to us. So it says a secondary stress. Actually, obviously, another thing is secondary stress. What's secondary stress? This top chord right here, it has dead load. There is a load on there. There's a dead load on there, so you're going to see this, if that weighs, what, let's say 15.7, I'm making up some random number, pounds per linear foot for this. Let's say you have a double angle. So this is a cross section right here. This is looking at a cross section. Let's call it A. Section A. All right. Let's say it's a double angle, like so. And this will have dead weight. This is going to have dead weight. So theoretically, this is not being loaded only at the panel points. It's being loaded on every single one of these as a dead load. But for a majority, those are, I mean, in the grand scheme of things, hopefully that's going to be very minimal. So you just assume that that dead weight is distributed equally. So you're going to load that dead weight right here, half right here and half right there for that top chord piece, and so on. And you can do that over, so for instance, this diagonal, half of it will be loaded up there, half down here, or you can do it the other way. You could load everything down low, or however you want. What you could do is you could say, hey, you know what, I'm going to take this entire, what is the average of this entire dead load truss? Because if you look at it, you could just take the average, and that would probably be fine. And you could just load it on top here with everything else. And some people might not even, they might discount the weight of that truss 100% and say, oh, it'll be fine. I would not do that personally. I would do just a quick dirty, say, okay, how much does the top chord weigh? How much does the bottom chord weigh? How much is a diagonal weigh? Because you're going to have that everywhere. And then every once in a while, you'll have these verticals. So maybe take the weight of this, and this, top chord, bottom chord, diagonal, and put it on top like that, and then just make these verticals point loads up here, and call it good. I mean, in the end, that's how you want to load it. Anyways, I think we've been done with that. But those are called secondary stresses. And primary stresses are, it's going to be bending or whatnot. The primary stresses are going to be your tension and compression. And you want to load these in a different way. So you really want to ignore them, is what I'm trying to get at. You're not really ignoring them, you're putting them in a different way, but you are ignoring them. So right now they're saying that secondary stresses are often ignored. I would say that's pretty true. Maybe not 100% true, but I think that's what they're getting at, and I say yes. All right. B, bending and shear stresses caused by joint restraint. And that's another issue, is these are not perfect. If you look at these are not perfect pins by any. You'll have a gusset plate or something. And this is obviously a larger bridge, truss bridge. You have a gusset plate, which is, it's just a big old plate of steel. And you'll have something coming in here. This is, you can't really see it. Here's your top chord, Maybe this top chord runs all the way through. Let's say you have a vertical bar coming in, and then you have another diagonal coming in. I'm sorry if this is a little too nasty. But I think you get what I'm trying to do here. And then this will, let's say you've got a row of bolts right there, you've got some bolts up here, and some bolts right here. I probably should put this in different colors, but I won't. I think you get what I'm trying to say. So in reality, are these going to move? Ever so slightly. It's not a perfect pin. A perfect pin is if you have a bolt and a member, and it's going to move freely. It's going to be able to rotate freely. That's what your pin is going to do. This is not a perfect pin, but theoretically, you're looking at this like it's a pin. And theoretically, this is the given. This is how trusses are designed. It's theoretically it's a pin. Don't worry about it. Anything else is secondary stresses, and you ignore them. So, like we just said, bending and shear stresses caused by joint restraint. Yes, that is what a secondary stress is. But so that's incorrect. Or it's the correct answer, and that's not our answer we're looking for. C, stresses in truss members other than the chords. And that is actually incorrect. Because secondary stresses, that's saying that in other than the chords. So that's saying that, hey, the stresses in this diagonal are secondary stresses, and that's incorrect. That's going to be a primary stress, because you're going to get stuff coming in here that will, some of it will be resisted there, some of it will come down here, some of it may come down here. I think you get what I'm saying. 1 minute. So you can see that's the incorrect answer. because that is a primary force. That diagonal is going to see tension or compression. That's what they're in there for, because the triangles make up it makes up a truss. If you don't have that triangle, it's not going to be a truss. Because if you don't have the triangles, if you take out those diagonals, you're going to have to resist moment some way in this truss. So it would have to you'd have to consider those as fixed. So anyways, once again, secondary forces are created by the fact that this isn't a perfect pin, and you generally neglect those. All right. D. Necessary to consider when designing primary trusses spanning long distances. And that's once again incorrect, because this is pretty much what we were looking at, is a long span. I was looking at the longest spans you get will typically be for large loads will be bridge trusses, and you do not consider them. I think you should take a look at them and see if something's going to be an issue, but in truss design, that's generally not how it is. All these end up going through the same point, and that's part of truss design as well. This is a center line. Okay, oh well, these are all center lines of these members. So they will all come into one point, and that is what makes it theoretically a truss. All right, I think I've beaten that again. That horse I always beat. So I will see you on question number 5. I hope that was helpful.